Hi everyone. So today we'll do jam previous year question of the chemical kinetics topic. So in my last video I uploaded from 2018 to 2021. So in this video I'll cover from 2014 to 2017. So you know that the chemical kinetics topic is very important for in every perspective of jam, CSN, NET and GATE exam. So in my future video I'll cover from for NET or GATE exam, and today we'll do for this 4 year jam previous year question. Okay, so let's start this video. Okay, so in our the first question is a the first order reaction A to B to B plus C, the rate constant in terms of initial pressure P0 and the pressure at time t is Pt is given by which equation? Means the rate constant we have to calculate. Okay, so the equation is, we can write this equation as 2b plus c at t is equal to 0, that is the initial pressure is P0. Okay, and this pressure will be 0 obviously at time t, time is equal to t time, that is P0 minus x. So we can, the pressure of B will be 2x because the stoichiometric is 2 here, and here it is x because here it is 1, the stoichiometric. So our total pressure at time t, what will be the time? That is Pt is equal to P0 minus x plus 2x plus x. We have to sum all this data, so that will be x and x cancel out, P0 plus 2x. So from this equation we have to know what is x. X is equal to Pt minus P0 by 2. Okay, so what will be our P0 minus x? Hence I will tell why we need P0 minus x. Okay, so P0 minus x will be P0 minus Pt minus P0 by 2, that will be 3 P0 minus Pt by 2. So we know this. Okay, now from the first order reaction, what is the first order reaction? Means equation, reaction equation, that is, you know, time or rate constant k, that is 1 by t ln P0 by P0 minus x. Why I am writing this like so? In means in ordinary case, when the concentration is given, then the equation is k is equal to 1 by t ln a by a minus x. A is initial concentration and a minus x is the concentration left after time t, okay, of the reactant. So in this case the pressure of at time t of the the pressure of A is P0 minus x. So I have to calculate this P0 minus x. I calculated this one, so we just write this one, 1 by t ln P0 by that is P0 minus x is equal to 3 P0 minus Pt at 2 will rise. So this is our equation, that is 1 by t 2 P0 by 3 P0 minus Pt. Okay, so that B option is our correct option. Okay, so this is the whole process, but if there is another short trick for this question, you can remember that also. what will be the short trick? So that is, we can write any equation such type of means any this type of equation like k is equal to short trick. Okay, but just understand the concept only. You means the short trick you can forget in exam, but if you know the concept you can derive the whole the equation. Okay, so that is short trick to do the question quickly. Okay, so that is k is equal to 1 by t that is we can write a p I by b p I minus c p t. So what is a, b and c and pi? Pi is initial pressure, initial pressure. So here it is p0. Okay, and pt is pressure at time t. Okay, so a, what is a? A is stoichiometric, means stoichiometric of product minus stoichiometric of reactant. Okay, a. So what is that? Stoichiometric of product here 2 plus 1, that is 3. The 3 minus 1, because a is stoichiometric 1, so 1, that is 2. And b is stoichiometric of p. P means product. Okay, stoichiometric of product, that is product stoichiometric 2 plus 1, that is 3 here. And c is stoichiometric of reactant. Okay, reactant, that is 1, because a for a. So if we write this here 1 by t, a means here 2, pi is p0 here, by b, b is 3 minus p0, sorry 3 p0 minus c is 1 pt. So I can easily derive this one. This is a short trick, you can remember this one, but this is the whole concept, you just have to remember. Okay, so next question. What is the next question? That is for a reaction 2a plus b to c plus d, if the rate of consumption of a 0.1 mole liter inverse second inverse, so rate of production of c, what is the rate of production of c? So our next question is, so that came in Jam 17. Okay, so that is for a reaction 2a plus b to c plus d. So if the rate of consumption of a is 0.1 mole per liter per second, then the rate of production of c, what is the rate of production of c? So from the equation, from the question, we can like dA dt is equal to 0.1, unit is there. Okay, I'm not writing the unit is mole per liter per second in every case. Okay, and it asking about dc dt, it's minus. Okay, because this is reacts, why this is minus? Because it is reactant, a is reactant but c is product. So rate of production of c will be dc dt, that is positive, but the rate of consumption of a, that is negative, that is dA dt. Okay, so dc dt, so they're asking, so from the equation there's 2a plus b plus into this equation, we can tell that minus 2 by dA dt is equal to dc dt. Okay, so dc dt will be minus 2 by 0.1, so minus 0.05 unit is there. Okay, so these are answer, but this is negative, but we will not write the negative here because rate will always be positive. If it is negative in result, but it will not write is negative, so our answer is positive, that is 0.05. okay, there is 3 questions from chemical kinetics. Okay, so what is the question? A radioactive element undergoes 80% decay in 300 minutes. Okay, half life, they are asking about the half life. Okay, just remember radioactive decay is always first order reaction. Okay, follows the first order reaction kinetics. Okay, so we know we have to calculate the rate constant because T half is equal to 0.693 by K. We just have to calculate K, and for K we know K is equal to 1 by T ln A by A minus X. A is the initial concentration, and A minus is the concentration remaining after time t of the reactant. Okay, so here 80% decay means 20% is remaining is, so in time is 300 minute into ln A by, means here A minus 6 is 20% of A because 80% has decays, so it is 0.2 A0. It's A, sorry, that can also be, we can write is A, so that is 0.2 A, so that is 1 by 300 into ln 5. Okay, that is K. We just put it here 0.693 by 1 by 300 into ln 5. So if you calculate this one, so this will be 129.20, so that is the unit is minute. Okay, so this is our answer. So next question, is from jam 16. so that is rate constant for a reaction 300 Kelvin, 2 and 350 Kelvin, that is rate constant are given at 8 and 160 liter mole in per second inverse. Okay, respectively, and the activation energy. So from Arrhenius equation we know K is equal to A e to the minus EA by RT. Okay, from this we can derive that log of K2 by K1 EA by 2.303 into 8.314 T2 by minus T1 by T1 T2. You can derive this one because K2 by K1 you just need to put ln in each side, so that will be ln K is equal to ln A plus that will be, okay, ln A plus EA minus EA by RT. So if we do that ln K2 minus ln K1, from that you can derive this one, and log is just we know that ln x is equal to 2.303 log x. Okay, you can convert it yourself. Okay, so you just have to put everything here. That will be log of K2 is 160 by 300, that will be EA is asking, so 2.303 8.314 T2 is 350 minus 300 by 350 into 300. Okay, this is the equation. You just have to calculate EA. So I am giving the answer, that is answer will be, put it in the calculator, and this is very easy. That will be 52.3 something 31 kilojoule per mole. Okay, that is the answer. Okay, next question. What is the next question? That jam 15, that when the perfect monolayer of stearic acid is formed in air water interface. Okay, each molecule of stearic acid molecular weight is given, that is 284, and density is also given, just 0.94 gram per semi-cube, occupies the area of 20 angstrom square. They are asking about the length of the molecule. Okay, given is molecular weight, that is 284, that is the unit, this is gram per mole. Okay, density is given, that is 0.94 gram per semi-cube. Okay, and the area is given, that is a 20 angstrom square. Okay, they are asking about the length. So we know that D's density is equal to m by v, mass by volume, that is a m by volume is here area, that is a into length. So our length will be m by a into d. Okay, so here m is, you just take care about the this units. Okay, m is, so you just write everything with data in this equation. Now the unit also you just have to write. Okay, so m is 284 gram per mole. So gram per mole, mole inverse, so we can write it, mole is 6.023, 1 mole is 10 to the power 23, 1 mole is equal to, so that will be 6.023 into 10 to the power 23. So that will be A. What is A? A is 20 angstrom square. Okay, and length, D is 0.94 gram per semi cube. So we can write it here, semi cube. Okay, so if you calculate this one, so what will be the answer? That is, gram cancel out, and 284 by this equation, so that will be 2.51 into 10 to the power minus 23 angstrom square into semi cube. So we know that 1 angstrom is equal to 1 10 to the minus 8 semi. So 1 semi will be 10 to the power 8 angstrom. So 2.51 into 10 to the power minus 23 into 10 to the power 8 the cube angstrom square into angstrom to the minus 3, that will be angstrom. Okay, so our answer will be, that is 8 into 3 is 24, as is a minus 23, so 2.5 into 10, that is approximately 2 point, we can write as 2.1 angstrom. Okay, so this is our answer, that is the length. Okay, this is very easy one, just have to remember that D is equal to m by v, and you can write, and you just have to take care about the unit, because that is very confusing here. So next question that came in jam 15. So the question is, the kinetics of 2N2O5 to 4NO2 plus O2 is liquid bromine medium was measured independently for three different initial concentration: 0.11, 0.07 and 0.05 mole per liter. Okay, they ask that they also said that the half life of the reaction is found to be 4.5 hour for all this concentration. So you just have to calculate that the order of the reaction. So you know that order of the means first order reaction. For first order reaction only, for first order reaction, half life is T half is equal to 0.693 by K. So there is no there is initial concentration is not there in the equation. So the half life is doesn't depend on the initial concentration. For any initial concentration we take, whatever we will take, the in all time the half life will be same. So our order will be reaction is 1, because it said that for all this case the half life is 4.5 hour. Okay, so next and last question, okay, that came in jam 14. So what is the question? The charcoal of 1 gram, 1 gram is charcoal is given, and the surface area is 100 meter square per gram. Okay, 1 gram have 100 meter square surface area, and absorbs 60 milligram of acetic acid from an aqua solution at 25 degrees Celsius and 1 atmosphere pressure. The number of moles of acetic acid absorbed per semi square of charcoal is. You have to calculate the what is the number of moles that absorbed by the charcoal of acetic acid. So they are asking about the moles, okay, and 60 milligram is absorbed. So CH3COOH, that is acetic acid. So molecular rate will be 12 plus 3, that is, and 12 plus 32 plus 1, that is 60. 60 gram is the molecular weight, and it is given that 60 milligram is absorbed. So number of moles absorbed is, mole is 60 milligram by 60 gram. So that is 16 into 10 to the minus 3 gram by 60 gram. So that is 10 to the minus 3 mole. Okay, that is absorbed by this charcoal. Okay, so 1 gram is given, and that have a surface area 100 meter square. Surface area of 1 gram, 1 gram is surface area of charcoal is 100 meter square, but they're asking about the semi square, so we'll convert it in semi square. Okay, so 100 meters square is equal to 100 into 10 to the power 2 third square meter square. So a semi square, that 1 meter is equal to 10 to the power 2 semi. Here 2 meters are there, so 10 to the 2 the square. So that will be 4, and this here 2, so 10 to the power 6 semi square. Okay, so we can tell that in 10 to the power 6 semi square surface area absorbed 10 to the minus 3 mole. Okay, so 1 semi square, they are asking about per semi square, so 1 semi square will absorb 10 to the minus 3 by 10 to the 6 mole, so that will be 10 to the minus 9 mole. Okay, so this is our answer. and the D is the correct option. So we completed from jam 14 to jam 17. So these are very easy questions are there, not difficult. In there's another important is this one, because this equation, from this equation you can see questions from this topic. Okay, so you just remember this one. You can derive this one from Arrhenius equation, but if you remember this one, it will be easy for you in the exam to do that. And other questions are also easy. Okay, so in my next video I'll cover the gate previous year question in this, for this topic, chemical kinetics, and we'll cover also the net previous year questions also. Okay, so I am ending this video here. So if you want such type of videos in future, so tell me in comment box, and if you like this video, subscribe my channel and tap the bell icon so that you can easily get my future videos. Okay, thank you, bye bye.